The Cold War was a time of intense rivalry between the United States and the Soviet Union. Both superpowers sought advantages in every domain, from nuclear weapons to espionage. One particularly ambitious area of exploration was weather control. The idea of wielding the power of the elements as a weapon was enticing. It promised a new form of warfare, one with potentially devastating consequences. Scientists and military strategists recognized the potential of weather modification. They envisioned manipulating rainfall patterns, intensifying storms, and even triggering droughts. Such capabilities could disrupt enemy supply lines, cripple infrastructure, and sow chaos among civilian populations. The allure of such power proved difficult to resist. The pursuit of weather warfare reflected the prevailing mindset of the Cold War. It was an era marked by paranoia, mistrust, and a willingness to push technological boundaries, often with little regard for the long-term consequences. The race to control the weather became another front in this global struggle. Perhaps the most infamous example of Cold War weather warfare is Operation Popeye. From 1967 to 1972, the United States Air Force conducted a top-secret operation over Vietnam, Laos, and Cambodia. Their goal was to disrupt the Ho Chi Minh Trail, a vital supply route for the Viet Cong. The method they employed was cloud seeding. Military aircraft flew into the clouds, releasing silver iodide particles. These particles acted as condensation nuclei, promoting the formation of raindrops. The aim was to extend the monsoon season, making the trail muddy and impassable. Operation Popeye did have a noticeable impact on the weather. The monsoon season was extended by an estimated 30 to 45 days. Rainfall increased significantly, causing flooding, landslides, and widespread disruption to enemy logistics. While Operation Popeye unfolded in the jungles of Southeast Asia, another weather modification experiment took place closer to home. In the United Kingdom, Operation Cumulus sought to explore the military applications of cloud seeding. Conducted between 1949 and 1952, the project involved releasing large quantities of dry ice and silver iodide into the atmosphere. The goal was to study the formation and behavior of clouds with an eye towards potential military uses. In August 1952, disaster struck the village of Lynmouth in Devon, England. Torrential rains exceeding 9 inches in just 24 hours transformed the small River Lynn into a raging torrent. The resulting flood devastated the village, claiming 34 lives and causing widespread destruction. While no direct causal link between Operation Cumulus and the Lynmouth flood was ever definitively established, the timing raised serious concerns. The proximity of the experiments to the disaster fueled speculation and public outcry. The controversy surrounding Operation Cumulus highlighted the potential for unintended and catastrophic consequences of weather modification. It served as a stark reminder of the unpredictable nature of the atmosphere and the ethical dilemmas inherent in attempting to control it. Section 4, Project Stormfury: Taming Hurricanes. Hurricanes, with their immense destructive power, also attracted the attention of weather warriors. Project Stormfury, a US government program that ran from 1962 to 1983, aimed to weaken hurricanes through cloud seeding. The idea was to disrupt the hurricane's structure by seeding its eye wall with silver iodide. The hope was to reduce wind speeds and mitigate the storm's impact on coastal areas. Project Stormfury involved numerous experiments, primarily in the Atlantic basin. However, the results proved inconclusive. Scientists struggled to determine whether the seeding had any significant effect on the hurricane's intensity or trajectory. The immense complexity of hurricane dynamics made it difficult to isolate the impact of the seeding. Despite some initial optimism, Project Stormfury was eventually abandoned. The scientific community concluded that more research was needed to understand hurricanes fully and to determine the feasibility of modifying their behavior. Section 5. The global implications of environmental warfare. Weather control experiments during the Cold War had global implications. These experiments raised concerns about environmental warfare. Nations manipulating weather for military advantage threatened international stability. In 1976, the UN adopted the NMOD Convention. This treaty prohibits hostile environmental modification techniques. Enforcing the treaty remains challenging. Section 6. The legacy of weather control experiments. The Cold War experiments in weather control, though largely abandoned, left a lasting legacy. They serve as a reminder of the potential for technology to be used for both beneficial and destructive purposes. While the dream of controlling the weather remains elusive, the lessons learned from these early experiments continue to shape our understanding of the atmosphere and the ethical implications of manipulating it. Today, weather modification research continues, albeit primarily for peaceful purposes. Cloud seeding, for example, is used in some parts of the world to enhance rainfall, suppress hail, and disperse fog. However, the legacy of the Cold War serves as a cautionary tale, reminding us of the importance of responsible innovation and international cooperation in the face of potentially dangerous technologies. The quest to understand and control the weather continues to fascinate and challenge scientists. As our technological prowess grows, so too does our responsibility to use these tools wisely and ethically. The experiments of the Cold War serve as a stark reminder of the potential consequences of unchecked ambition when it comes to manipulating the natural world. Section 7. Ethical considerations. Playing God with the skies. The pursuit of weather control during the Cold War raises profound ethical questions. Manipulating the weather grants humanity power over nature that demands careful consideration. The potential for unintended consequences is significant. One pressing concern is the issue of